Welcome students, this is Ravi Shankar. Today we are going to study about the working of a microwave oven. Usually you are seeing it in your kitchen. Now we are seeing it in physics. How this microwave oven works. What is the relation between the microwave oven and electrostatics? In our last class we have studied about the torque acting on an electrical dipole when it is placed inside an uniform electrical field. Based on that concept, we are going to study about the working of this microwave oven. Okay, so the basic principle is torque experienced on an electrical dipole when placed inside an uniform electrical field. Let us see. First of all, what is a microwave oven? It is a device. Okay, it is a device used with device to cook the food, particles or cook the food in a very short interval of time. In a very short interval of time. Okay, then when you are considering about this microwave oven, the basic principle is the torque produced. How? See, when you are placing the food materials inside the microwave oven, you will be mixing that food materials with water. The water molecules in the foodstuffs, okay, already we have studied the water molecules as permanent electrical dipoles. So, the water molecules in our foodstuffs or in the foodstuffs, which are the permanent electrical dipoles, which are acting as permanent electrical dipoles, Okay. Now, what happens when the oven is operated? When the oven is operated or when the oven is switched on, let us take like this, switched on, and uniform electrical field is developed due to the microwaves produced. So, when you are switching on, microwaves are developed. Which in turn produces an uniform, not uniform, because microwaves produces an non-uniform and oscillating. So let us consider like this. Microwaves are developed, which in turn produces and non-uniform, let us write like this, produces an non-uniform oscillating electrical field. See, you just consider this point again. When the oven is operated or when the oven is switched on, initially microwaves are developed. That developed microwaves, which in turn produces a non-uniform oscillating electrical field. Inside this non-uniform oscillating electrical field, we are having the water molecules, which are the permanent dipoles. So, when the oven is switched on, microwaves are developed, which in turn produces non-uniform oscillating electrical field. Inside this field, the water molecules present get excited, or we can say produces a torque, produces a torque and try to rotate, produce. If torque is produced, it will try to rotate. Try to rotate. When it tries to rotate, it develops thermal energy or the heat energy. Try to rotate. When they try to rotate, it develops or produces, develops thermal energy. Develops thermal energy. This heat energy produced or this thermal energy, this thermal or heat energy produced, thermal or heat energy produced is used to cook the food, in a short interval of time. In a short interval of time. This is the answer. Time. That is, it can be cooked easily and it is fastly. See, I want to explain this again. See, how this thermal energy is produced due to torque. Let us again see. What is a microwave oven? Microwave oven is a device which is used to cook the food in a very short interval of time. The basic principle is when the dipole is placed inside an uniform electrical field, then that dipole will try to produce an torque. That torque will produce heat energy. Here, the water molecules in the foodstuffs, which are considered to be permanent electrical dipoles. When the oven is switched on, what happens? When the oven is switched on, the microwaves are developed, and the developed microwaves, which in turn produces a non-uniform oscillating electrical field. This non-uniform oscillating electrical field, inside the microwave oven, inside which the water molecules present, produces a torque. Usually we will be saying the water molecules will get excited, then it produces a torque because of which it will try to rotate. When it tries to rotate, the covalent bonds among the water molecules will get broken. When the covalent bonds gets broken, large amount of heat energy is developed. That is how you can able to get that thermal energy. But in your book it was being given like this. Inside this non-uniform oscillating field, the water molecules which are present produces a torque and it tries to rotate it. When it tries to rotate it, develops thermal energy or heat energy. This thermal energy or heat energy produced is used to cook the food in a short interval of time. Clear? I think you should have understood this. Thank you. Let us see in the next video.